In number 1, they talk about folding a postcard in half. If I have my postcard and then I fold it in half and I rotate it continuously, which of these objects is generated by this rotation? The choice is number 3. If I were to bring in the three-dimensional object like choice number 3, imagine me putting this card in and being able to spin and rotate this image anywhere in this glass. Can't be any other ones because, like for number 1, the corners would have to be like cuts diagonally. Okay, so if you can imagine this piece of postcard being able to be rotated in this object. Number 2, a 3-inch line segment is dilated by a scale factor of 6 and centered at its midpoint. What is the length of its image? In this case, what we're doing is we're taking 3 inches and multiplying it. Dilation basically means multiplication by 6. 6 times 3 is going to be 18 inches. My little diagram here may not be drawn completely to scale, but 18 inches is your answer. After step 1, when the student got to this line in step 1, what you're doing is you're taking half of 4 and squaring it. So half of 4 is 2, squared is 4. But whatever you do to one side, you have to do to the other. Okay, it looks like in this case, he did opposite signs. Okay, you do opposite signs when you're working on the same side of the equation, but since you're working on 2 different sides, okay, you have to add whatever you do to one side, you must do to the other side, the exact same step to keep the balance. Okay, choice number 2. And number 4, a translation of 2 units down is the result results in an image parallel. Imagine I just slid this down. I just literally just dragged this down 2 units. I didn't change its angle with the axis. It looks like in this case these 2 lines will never share any points, which results in parallelism. Choice number 1. In number 5, if you notice, what we have here is corresponding sides. If you notice that this was increased by a scale factor of multiplying by 8. This one is multiplying by 4. They have to be, in order to be similar, they have to be multiplied by the same scale factor. For example, in this one, side 4 corresponds with side 12. 4 times 3 is 12. This side corresponds with that one, and if you notice, 3 times 3 is 9. They were still both multiplied by 3. For number 6, to solve this problem, what we're going to do is find the volume of the cube. Here's my cube. We know each side is 8.5, so length times width times height is 8.5 times 8.5 times 8.5, or it's the same as 8.5 to the third. If you notice, all of these choices have that. Now we have to find the volume of this circular cone, part of my drawing. You have 1/3 pi r squared h. Well, we know that my radius is going to be half of 8, so it's going to be 4. And the height, as described in the word problem, is going to be 8. So using your knowledge of the formula, choice 4 is your only appropriate choice. Number 7, 2 right triangles must be congruent if what I do here is I show by counterexample or elimination. Number 1, here's my example number 1. Like here's 2 triangles, obviously of the same, different sides. They're not congruent. These angles are the same. An acute angle is basically, any of the angles that are less than 90. Number 2, that's the best I could draw here. I use my ruler, and this is both these are about a scale factor of 5 inches, but they look different. They're not my best drawings. I apologize. Number 4, here's two triangles with the same area, but clearly different sizes. What's 1/2? This is 12, and then this is 12 as well. Okay, choice number 3. And number 8, it looks like you would need to rotate this 90 degrees to get vertex A into the second quadrant, vertex B into the third quadrant, and C into the fourth quadrant. So after it does that, it looks like it's made bigger, it's scaled more by a dilation. So in this case, the only choice that has dilation and rotation is choice number 4. Okay, number 9, I drew a parallelogram. Now in this case, it looks like BC is longer than AB. My drawing is not necessarily a rhombus, but remember, in order to be a rhombus, consecutive sides need to be congruent in a parallelogram. So this one has to be congruent to that one. So that does not prove that. Excuse me. AB congruent to BC would prove that it's a rhombus, but it's asking you which one does not. Okay. Another thing is that diagonals are perpendicular in a rhombus. So if these, intersected, so let me try to draw a better. A rhombus is basically a tilted square. So if we have A, B, C, D intersect at E, this is congruent to this. This are perpendicular. So sorry about that. AB is congruent to BC, and these are perpendicular. So it's not choice 3. We also know that in a rhombus AC that diagonals bisect the angles. So we know that this diagonal is going to make this congruent to that. Okay, so the only choice left is choice number 1. The reason being is because AC being congruent to DB, it could also make it a rectangle.